Today's lesson is called Advanced Strategies for Factoring Quadratic Expressions, Day 2. We'll start with the opening exercises. It says to factor the following quadratic expressions. So you have number 1 and number 2. Please pause the video while you try these problems on your own, and when you're ready to go over the answers, you can resume the video. Okay, at this time you've had a chance to try the 2 opening exercise problems. In number 1, we want to factor out a GCF first. Now remember, we learned GCF earlier in the chapter. If there's a GCF, it is always helpful to look for that first and factor that out, which could potentially make your factoring much easier. So now we're factoring x squared plus 5x plus 6. So the factor pairs of 6 that add up to 5 are 3 and 2. So you should have 2 times x plus 3 times x plus 2. In number 2, there is no GCF, so you have to factor this trinomial that has an a value that is not a 1. So you use your trial and error method to do so. You get 3x minus 2 and 2x plus 3. If you want to check any of these answers, remember you need to make sure that each factor is prime. There's nothing else that can be factored out. And that if you multiply them back out, you get the original expression. Today, we're going to learn a method that will actually be helpful in factoring these trinomials when the a value is not 1, so that you don't have to guess and check. So we're going to learn splitting the linear term today, which again is an alternative to guessing and checking. So we're going to write instead of guess and check. Now, of course, guess and check can still be a strategy you use unless the question asks you to do otherwise. If they specifically ask you about splitting the linear term, then you would have to do it. But this is a nice one because there's a specific process that you can follow every time to be able to successfully factor a trinomial when the a value is not a 1. So it says, how might we find the factors of 6x squared plus 5x minus 6? So you'll see in step 1, it says multiply a and c. Let's go up here and take a look and label all of our a, b, c values. So a is the coefficient of the x squared term, so our a is 6. B is the coefficient of our middle term, which would be a 5. And C is our last constant number, which is negative 6. So in step 1, it says multiply A and C. So that means we're taking 6 and negative 6 and multiplying them to get negative 36. That's the first step in the process. Step 2 wants us to list all possible factor pairs of AC. So normally we would just list the factor pairs of C alone. With this process, you have to multiply A and C first, and now that's the number we're listing the factor pairs of. So our AC value is negative 36. So we would have 1 and negative 36, negative 1 and positive 36. We would have negative 2 and 18, 2 and negative 18. I typically work my way up from 1 and up, and then once I get my first repeat, I know I'm all set. And I do them in pairs. So then if I go 3 does go into negative 36. So I would have negative 3 and 12, and 3 and negative 12. Then we have our 4s. 4 does go into 36. So we would have negative 4 and 9, and 4 and negative 9. And then 5 does not go into it, but 6 does. So we would have 6 and negative 6. So now in step 3, it says find the pair that satisfies the requirements of the product sum method. So this part is still the same. We want it to add up to B. So our B value was 5. So we want to look at our pairs and pick a pair that's going to add up to 5, positive 5. And if that's the case, we want to use negative 4 and 9. Because negative 4 plus 9 gives me the middle term, which is 5. Now in step 4, rewrite the expression with the same first and last term, but with an expanded B term using that pair of factors as coefficients. So we're going to keep the 6x squared, because that was the original first term. We're going to keep the minus 6, so it says keep the same first and last. But now the positive 5x that was in the middle, we are going to now break it up into the pair that adds up to the 5x that we found in number 3. So we would do minus 4x plus 9x. So you can see I'm taking this from here and using it down there. So now in 5, it says we now have 4 terms and can enter them into a rectangle or factor by pairs. So if I show you what it looks like in the rectangular form, of how we usually multiply it out, it would be 6x squared minus 4x plus 9x minus 6. So the common binomial factor presents itself. We're going to rewrite by combining the coefficients of said common binomial factors and multiply by the common binomial factor. Okay, so that sounds very complicated and fancy. Let me break down for you what that means. Now that we have turned this into a 4-term polynomial right now, we are going to group them in the chunks that you see in the 2 rows in the diagram above. So when I write this, I'm going to take the 6x squared minus 4x, and I'm going to put them together as one binomial. Then I'm going to add to that the second binomial, which is 9x minus 6. So I've just taken the 4 terms and split them into 2 binomials that we add together. So I'm just breaking them up into pairs. Now we're going to factor each pair. So let's make little notes. We're going to break up. We're going to factor each binomial. Okay, so now we're going to factor 6x squared minus 4x. So first I'm going to look for GCF. I have a greatest common factor of 2x. So 2x outside of, when I divide that out, I get 3x. And then negative 4x divided by 2x would be minus 2. Then when I do it for the second one, I have a greatest common factor again, this time of 3. 9x divided by 3 would be 3x. Negative 6 divided by 3 would be negative 2. So what happens is what they said over here. It says the common binomial factor presents itself. So what's happening is right here and right here, we have the same binomial in each of these different settings. So that means we're going to take this out, and it's going to become the first factor, 3x minus 2. And then the remaining pieces, the 2x and the 3, are going to come out and create the second binomial. So my factored form of this trinomial is 3x minus 2 times 2x plus 3. Now, if I want to double check to make sure that it works, remember I could come over here, set up my boxes, and actually multiply it out. 3x minus 2, 2x plus 3. 3x times 2x would be 6x squared. 3x times 3 would be 9x. Negative 2 times 2x would be negative 4x, and negative 2 times 3 would be negative 6. So then if I were actually to combine those terms, I'd have 6x squared plus 5x minus 6, which if we go back up, matches the trinomial that we had before. So this checks and it's okay. At this time, if your teacher has provided you with a practice activity, you are done with this video and you can go do your separate practice. If you are asked to do the practice and try it out in your notes, at this time you would pause the video and you're going to try the try it out problems where it says factor the following expressions using your method of choice. After factoring each expression completely, so you're factoring completely, check your answers using the distributive property, or you could use the boxes. Remember, always look for a GCF prior to trying any other strategies. So always look to factor out a GCF first. At this time, you can pause the video and then resume the video when you're ready to go over the answers. Okay, now that you've had a chance to try out the problems, we're going to go through them. In number 1, there is no GCF, so I'm going to multiply A and C because I chose to use splitting the linear term, but you could have also guessed and checked. I did 2 times negative 10 is negative 20. I'm looking for the factor pair that adds up to the middle number, so I needed to add up to negative 1, so that would be 4 and negative 5. Then you can see on the right-hand side, I split that middle term into 2 pieces, 4x and negative 5x. I grouped the first 2 together and the last 2 together, factored each one, and found the common factor of x plus 2 times then the remaining parts, 2x minus 5. In number 2, again, there was no GCF. So we are going to do 6 times negative 20. Now, when you have a large number like that, when it comes to listing the factors, I don't expect that forever you will be listing all these factors on paper. You can start to just investigate on your calculator and find the one that you need that way. So that's what I tried to show here, number 2, finding the pair that works and showing you it works. Then over on the right-hand side, you'll see that I split 7x into 15x minus 8x. First two go together in the one binomial, last two go together in the second binomial. You factor each one, you end up with 2x plus 5 and 3x minus 4. Now in number 3, there was a little bit of a trick I'll talk to you about when we get there. No GCF, so a times c is 4. I need the factor pair that's going to add up to 4x, so that would be 2 and 2. So 4x gets split up into 2x and 2x. Now when you go to group these into the first polynomial and the second polynomial, or binomial I should say, okay, we run into an issue here where this looks like it's already factored. So in order to make this splitting the linear term method work, you actually have to factor out a 1, which I know doesn't really do much of anything, but what it lets you do is then later when you're trying to make your second binomial, you have two numbers or two expressions to use. So you should get 2x minus 1 and negative 2x plus 1. Now, if you factored out a negative 1 as a GCF and then factored the remaining piece, you probably have an equivalent expression. If you're not sure about it, make sure you ask your teacher. Okay, now for number 4. It says the area of a particular triangle can be represented by x squared plus 3 halves x minus 9 halves. What are its base and its height in terms of x? Now, just thinking forward even a little bit, we should know that for the area of a rectangle is 1/2 length times width. So there really should be a 1/2 out in front. Now, let's look at this expression. That's going to be hard to factor, this 9 halves, okay? So what we want to do actually first is this note over here, factor out the 1/2 so that we're dealing with a trinomial that's factorable much easier than what we're looking at right now. It's not mandatory, but you would end up having to factor out the half later anyways. So if you take the half out now, you're just factoring 2x squared plus 3x minus 9. So 2 times negative 9 is negative 18. You list your factor pairs and find the pair that's going to add up to positive 3, which is negative 3 and 6. So over here on the right, I kept the 1/2 the whole time because it was factored out as a GCF, and I did my normal splitting the linear term process. So I end up with 1/2 2x minus 3 times x plus 3, which means the length is 2x minus 3, and the width is x plus 3. If you switched which one was length and width, it wouldn't matter, as long as you have the right two expressions. And that concludes your lesson on advanced strategies for factoring quadratic expressions, day 2.